This is Louis, and today I'm going to be doing my combining transformations video assignment. So to start, the function that I chose to do is f at x equals the square root of x, so that's the root function. And the transformation that I made on this function is f at x equals -4 to the root 2 bracket x minus 5 close bracket minus 6. So I already drew in my parent function, so that's f at x equals the square root of x, and that could also be y equals the square root of x. Likewise, f at x also means y. So these are my coordinates for this over here. And to start, I also made a checklist to make sure I have everything done. So to start, it's important to start with stretches and compressions. So I'm going to start with the inside of the root. So the inside of the root, we can see that there's a 2. And since it is on the inside, the way I like to see it is that this over here is going to be all my horizontal transformations, and these on the outside are my vertical transformations. So there's a 2, so that's going to be a factor of 1/2. That's going to be a horizontal compression by factor 1/2. That means all my x coordinates from my parent function are going to be divided by 2. So I'm just going to put in my coordinates. So 0 divided by 2 is going to stay 1/2, 4, it's going to be 2, sorry. And then that's going to be 4 1/2. And then all my y coordinates are going to stay the exact same, just like that. Alright, so next is going to be the other. So this is my horizontal compression. Next is my vertical. Over here, outside of the bracket, there's a 4. This means that there is a vertical stretch since it is more than 1. It's a vertical stretch by a factor of 4. So next I'm going to multiply all my y coordinates by a factor of 4. So all my x are going to stay the same. Oh, and as for this over here, so the idea of this is going to be around here. So that is that transformation. So this one, since I'm going to multiply all these by 4, 0 times 4, it's going to stay. 2 times 4 is 8, 3 times 4 is 12. So as for these, since this is a vertical stretch, this is going to end up being a little something like this. That's how my graph would look like. This isn't exactly accurate. If I were to plot these, that would be accurate. But next is I'm going to be doing the negative. So over here you can see if there's a negative outside. So that means that there is going to be a vertical, it's going to be a vertical, not vertical, it's going to be a reflection on the x-axis. So that means all my y coordinates are going to be negatives. So I'm going to keep all my x coordinates once again. 1, 1, 2. So all of these are going to be negatives. Just like that. Next, so as for that would end up looking over the x-axis. So it's going to look a little something like this. This is just a rough draft. So you can get the idea of that. Get rid of that. Okay, that's gonna be a rough draft. Next, so my compressions, that is all done. Next is my translations. So over here on the inside of my function, you could see that there is a -5, x minus 5. Since it's on the inside of the root, that means it's going to be a horizontal translation. And since it's a negative, it's going to be the opposite. So it's going to go to the right. So it's going to be a horizontal translation by 5 units. On the outside, there's a -6, which means that there's going to be a vertical translation by 6 units down, since this is a negative. So this means that all my x coordinates are going to be added 5. All my y coordinates are going to be subtracted 6. So doing this, that would be 5 1/2. Sorry. 7. Sorry, that's not my, why did I think? -6. that is going to be minus 10, 7, minus 14, minus 18. So doing this, again, an idea of this would be, so 5 units right, 6 units down. So it would look a little something like this, but just to plot it, so this is going to be the accurate transformation of my function. So this is going to be 5 and minus 6, so that starts here. 5.5 and minus 10, so that's around here, and minus 10, so it's going to be a little bit like around there. 7 and minus 14, so that's going to be 7 and minus 14. I guess that's pretty accurate. 9 and minus 18, that's going to be around here, and minus 18, a little bit off, so that's going to be, I can get rid of these. So connecting these, and then minus 18, so that will look a little something like that. So that is my overall function. If I erase all of these, if I erase all of these, so my parent function overall, it was horizontally compressed by a factor of 1/2. It was also vertically stretched by a factor of 4. It was reflected on the y-axis, reflected on the x-axis just over here. It was also translated 5 units right and 6 units down. And you can check these off. So all my transformations have been complete.